Hello everyone. In this video, we are going to look at the techniques for validating frame preemption capable time-sensitive fronthaul. I am Avik Bhattacharya, Product Manager for Network Testing Solutions. The functional component of a 5G Cloud RAN architecture are the ORU, ODU, and OCU. The transport network between ORU and ODU is known as the front haul, between ODU and OCU is the mid haul, and between OCU and gateway is known as the back haul. These transport networks are different in many aspects, such as latency tolerance, traffic encapsulations, etc. The ORAN fronthaul architecture demands bounded latency for time-critical traffic, mainly the EC pre-IQ samples. And the use of jumbo frames is normally avoided as they can impact overall latency of the network. Frame preemption comes in as a solution, assuring bounded latency for fronthaul traffic in presence of jumbo frames. Traditional Ethernet is designed on the concept of best effort delivery, which doesn't guarantee bounded latency. A large but less critical frame in transmission can make a time critical frame wait and therefore increase its transmission latency. Frame preemption allows the bridges to pause transmission of non-time critical frames when a critical frame is about to egress. Transmission of less critical frame can resume afterwards. Frame preemption is a new technology that's coming into the switching hardware. While adopting the technology, the network designers need to think if all components are working properly, starting from the adherence to the QoS priorities or the fragmentation and reassembly functions in the switch. And finally, if the frame preemption is actually able to ensure the end-to-end bounded latency. Preempting non-time critical traffic can result in erroneous fragment generation. Improper implementations can cause consequences such as a switch can generate erroneous fragment, which can jeopardize the time criticality of the fronthaul network. Or while preempting, the preempted frames can suffer from added overhead of inefficient reassembly. To validate frame preemption, the switches can be connected with IxNetwork Ethernet test ports with relevant interface speeds such as 10 gigabit or 25 gigabit. One of the important tests to be performed is to measure the latency of the express traffic in presence of preemption. This can be performed by using IxNetwork test ports to generate both express and preemptible traffic. The receiving test port can check for proper fragmentation done by the switch and also measure the express traffic latency. The test is performed in very simple 3 steps. Configure the express EC pre and preemptible M-plane traffic, start the simulation, and finally verify the results. IxNetwork TSN Wizard provides a very easy way to configure the traffic mix with flexibility to select the test topology and the objective of the test. Individual traffic flows can be configured with proper VLAN priorities as per the network configuration. The user can also select a frame size to match the actual EC pre and M-plane flows in the fronthaul. The data plane statistics provides live measurements of the traffic characteristics in the network. The per flow latency statistics shows a comparison between the latency of the express EC pre-flow and other preemptible flows in the network. The frame preemption statistics flags any error in fragmentation done by the switch. The switch vendors also need to validate the reassembly function. This can be done by using the IxNetwork test ports to generate preempted fragments and measuring the integrity of the reassembled frames by the device on the receiving test port. IxNetwork allows the user to control each individual fragment to design a test. Each fragment can be changed to represent an erroneous condition. User can inject MCRC errors and check how the switch responds to such situation. The per flow statistics in IxNetwork measures if the device under test is able to successfully ignore the erroneous fragments and able to reassemble the correct fragments. Using these tools, the network engineer can easily validate the traffic characteristics of the xHaul frame preemption profile as defined in the 802.1 CM. The Keysight 5G RAN transport test solution enables the user in validating the important technology pillars of the RAN transport architecture, including time synchronization, deterministic transport or TSN, ECPRE, security encryption, SDN, and virtual infrastructure. The broad product portfolio covers all of the network engineers' need for conformance, functionality, performance benchmarking, and high-scale load testing of the 5G RAN transport. Thank you for watching this demonstration.